Hello and welcome to the Calculator Guide video on the Newton-Raphson iteration quick calculator method. I'm going to show you this by use of a typical A-level type question on using the Newton-Raphson method. I'm actually going to do something a little bit different. I'm actually going to do part C first, which is the most calculator involved section of the question, and then later on in the video, if you're interested, if you keep watching, I'll go through part A and part B. So we're going to start with part C, and the great thing about the way the question is laid out here is that we can actually attempt part C without having done A or B first. And let's just have a read of the question, starting with x0 equals 4.5. Use the iteration formula that's presented there to find x5 to three significant figures. Now this is quite a quick method to do on your calculator. You need to start by inputting your x0, your starting value. So in this instance it's going to be 4.5. Enter 4.5 into your calculator. It's just changed it to a fraction there. That won't matter. It won't alter any of the calculations by doing that. The important thing is now that 4.5 is currently our answer, and we're going to use the answer function to help us with the iteration process. The next thing you need to do is to input the iteration formulas. So we're going to start with a natural logarithm. It's opened a set of brackets for us already. And rather than writing x to the power n, remember that would be our x0 in this case, and we're looking to find our x to the n plus 1 or x1. We're going to use answer. We know that's x0, we've just inputted that. So we're going to use answer, and that's quite a critical point for the whole process of the future calculations we're going to do. So we're going to input answer. We notice that that is cubed, xn is cubed in the formula, and then minus 2, close our brackets and press equals. And the answer that we have here is our x1, and we're just going to make a note of that. Now to get our next value, x2, well, we don't need to import the formula again, we just need to press equals. And what the calculator is doing is it's using the answer from the previous calculation each time. So x2 will use x1, x3 will use x2, and so on. And we need to find x5, so we need to make sure that we've found the fifth result along. So it's always worth keeping a note. The examiner will want to see that information as well. And so here we've got a final answer. It's 4.47 to three significant figures. And so there we go, we've finished with part C. Let's go back now and answer part A and B. Well, the first part of the question says, show that the equation f equals 0 has a root near to x equals 4.5. Now what we're looking at here when we process this is we're looking for a change of the sign in our answer. That would indicate that somewhere between two values we have x equals 0, because one value will be negative and one value will be positive. And I'm going to use table mode to demonstrate this one. I quite like this because you get a lot of different results and it's quite clear to see where your root is. So I'm going to enter table mode, and I'm going to carefully input my function of x. So it's e to the power of x minus x cubed plus 2. So once I've inputted my function of x, I need a start value. You can start with 4.4 if you wish. I'm going to start with 4 just to give you a broader range. And then the finish value, I'm going to put 5. You could use 4.6, provided you're at least so many decimal places above and below where you're looking at. And the step is going to be 0.1. We're dealing with the first decimal place here. And if we scroll down our list of results here, once we get to close to 4.5, in fact between 4.4 and 4.5, we have a change of sign. Remember, we're looking for where the function equals 0, so it's going to equal 0 somewhere between 4.4 and 4.5. And this ties in nicely with the solution that we already know of 4.47 from part C. If we're doing this in order, we wouldn't, of course, know this at this stage. And what we need to do now is to write down what the value for 4.4 is, what the value for 4.5 is, and then explain that there must be a root between these two values because we have a change of sign, and f equals 0 must occur between those two values. So finally, part B, we need to show that the equation, and there's an equation there that we've just inputted into the calculator, can be written in the form x equals the natural logarithm of x cubed minus 2. And this really is a non-calculator method. It's a bit of algebraic manipulation. Ultimately, to get the equation in the form x equals, we're going to have to take the natural logarithm of the values that we have here. And the best way to do that is we need to rearrange the equation so that we have e to the x on one side of the equation and then the other values on the other side of the equals. So what I'm going to do is add x to the power of 3 minus 2 to each side. And so I've got e to the power x equals x cubed minus 2. and then what I'm going to do is take the natural logarithm of both sides. So the natural logarithm of e to the x is just x, and then we've got the natural logarithm of x cubed minus 2. So 2 steps there, and that shows everybody that you've been able to rearrange the equation in the form that they've requested. And then that would lead on to part C. If you notice the similarities there between the equation that you've just found and the iteration formula, it's very similar. The only difference is we've got xn and xn plus 1. So we're gradually, as we keep testing our answers, get closer and closer to the result that we're after. So that's it for this video. I hope that's made the iteration process a little bit clearer for you. I'll see you next time on the Calculator Guide.